So here we can show that if a sequence has a limit that goes to 0, so as n gets larger, this sequence term gets smaller and smaller, we can consider that they may have a finite limit, or they may converge. So if I have this is a geometric sequence, so each term is r to the power n. In this case, we've set r to be 0.5, so it's going to be, we're going to start at 0.5. So the sum of that, the sequence term is 0.5, and the sum of the first sequence is 0.5. So we can continue this, and we can drag this along, and we can make this go to the next term. Okay, so there's 2 terms, 3 terms, 4 terms, 5 terms, 6, 7, and we can see that as we increase the number of terms, okay, you can see how the sequence is going towards 0, and we can see how the series is getting closer and closer. In fact, it's got so close to 1 that, in fact, the sum is being calculated as 1. Okay, so we can see that happening. So that's a geometric sequence, and it did go to 0. Okay, so it did have the possibility of having a finite sum. In fact, all geometric sequences have finite sum. If I change that even to 0.8, okay, and I can reset this. Reset this here. I can go backwards here, and we can see that even if we have a series where the r is quite large, it doesn't go down very quickly. Eventually, it will start going down fast enough, and then again, it will reach a finite sum. Okay, so the finite sum is going to go up and kind of level off there. And you can see the sequence is going to 0. Now we can take a look at some other sequences. So, for example, a harmonic sequence. Okay, so this is a harmonic sequence, and we can see that harmonic sequences, they're just like with geometric sequences. The terms do go to 0. Okay, so the sequence does go to 0. But in this case here, the harmonic sequence, just make p equal to 1 here. Okay, so this is a harmonic sequence. A harmonic sequence does not, okay, it seems to grow and grow and grow and grow, and as we keep on going, okay, it doesn't seem to ever have a finite sum. In fact, if I show the sum of the series, the sum does not exist. It just keeps on going. It doesn't level off fast enough. Although the sequence goes to 0, we can see that down here. Okay, it doesn't level off fast enough. So we can look at our Basel series. So we'll make p equal to 2. Okay, the Basel series is slightly different in that if we add up the Basel series, okay, so just drag that along here. Okay, so we start with our Basel series. Our Basel series is going to be 1 over n to the power 2. So it's going to be 1 over 1 squared plus 1 over 1 quarter plus 1 over 1 quarter plus 1 ninth plus 1 25th, etc. And this one does definitely goes to 0 like all the other ones. The sequence goes to 0, but this one does have a limit, and this limit is limiting out at this value here. It looks like it's about 1.61. Okay, so this is an example of a finite sum of an infinite series. This is going to eventually have an infinite sum, and this one looks like it's 1.644. So that's a harmonic series that's not a harmonic series. This is a Basel series when the power is 2. The harmonic series when the power is 1. Okay, this one again, the sum does not exist. So depending on the power, the sums exist. If I make that power 0.5, okay, it doesn't go up fast enough, and again, this doesn't go down to 0 very quickly. So what ends up happening is this just grows and grows and grows, and again, the sum does not exist. Okay, so powers of bigger than 1, they exist. When the power equals 1, the sum does not exist. Okay, this is our harmonic series, and this is our boundary series. And if we have powers bigger than 1, the sums do exist. Okay, and we can take a look at an alternating harmonic series as well. Okay, so we're going to alternate this. So this is our harmonic series, and it just goes back and forth, back and forth, back and forth between positive and negative 1. And it works out that this one actually does. So works out between positive. So it goes positive 1/2, negative 1/3, positive 1/4, negative 1/5. It just bounces back and forth above positive, negative, and it does. This sum does tend to go to a finite sum. Okay, so we'll look at those a little bit later.